Hey guys, welcome back to another episode. So this is the part 2 of CI/CD implementation. So in the previous video, we already discussed about the theoretical part that is related to CI/CD and DevOps. If you didn't check that video, I'll put a link up here. Please go ahead and watch that if you don't have an idea about CI/CD and DevOps. And there we discuss what CI/CD is and the activities that is involved in CI/CD in the release process, and then the benefits of CI/CD, and also the CI/CD in the context of our Misfit web application. And finally, the last step is the implementation, which we are going to do today. So if you like my videos, take a moment to hit subscribe, click in there and hit the bell icon to never miss any updates. So I'd like to start this video with a quick diagram. And we already know there are several steps in the release process, starting from where you host the code or where you store the code in the centralized repository. And we mentioned in our application we are going to use AWS Code Commit as our centralized repository. So the users, or the developers rather, will push their code into the centralized place. What is another alternative, guys? Of course, it's GitHub. So rather than GitHub, we are using AWS Code Commit, another Git repository. So that is where the source code is. And what about the second step? That is the build step. For build step, we are going to use AWS Code Build. So this is a AWS service. So whenever a code is pushed to the centralized repository, we will trigger a build in the AWS Code Build. So AWS Code Build is going to provision a small server and then pull the code from this given branch in the AWS Code Commit repository, and then it will start building. So what's going to build, guys? So it's first going to look at the Docker file, and then it is going to execute each and every instruction and create the Docker image. As you already know, we are deploying a container into AWS ECS. So before deploying the container, we need to have a container image. So that's what will happen in the first step. It will run through the Docker image, or rather the Docker file, and create that Docker image. And then that image will be pushed to ECR, not to AWS Fargate, but to ECR, or Elastic Container Registry, where we are hosting our Docker images. So that's what happened in the code build, and we have discussed there's this special file called buildspec.yml, and it has this build step defines. There are three main build steps. First is pre-build step. So in the pre-build step, it's basically logging into the ECR, because ultimately we are going to push that image to ECR, right? So first we need to logging into ECR. So that's happening at the pre-build step. And the build step, that's the second step. It's going to look at the Docker file and then build the Docker image and tag it. That's happening at the build stage. And the post-build stage, it's going to push that Docker image into ECR. Since it already have a connection, it will push that into ECR. So that's happening at the build stage, guys. And what's the third step is the test stage. But in this application, we are going to skip that stage since we don't have any test or integration test as such. But by all means, in your enterprise application, you must have a test stage, because testing is utmost important. And then the last stage, it is the deployment stage. So we are going to use that Docker image at this deploy stage and create a container and host it in AWS ECS. And we have already set up our ECS cluster managed by the AWS Fargate, the managed compute from AWS. So what we are going to do, we just create an image or the container from the Docker image and host it in AWS ECS, right? And that's our backend. So our backend is already connected with the front end through the load balancer. And guys, connecting the load balancer with the front end and hosting it and all that we have covered throughout this series. So I recommend you to watch this series from the first episode so you will understand the flow. But now let's get started with the CI/CD architecture implementation. Alright guys, so this is our current application, and this is being served from a CloudFront domain URL. And if I hit enter, you can see the misfits or the items that is loaded in the application, which are misfit creatures, are being loaded from our backend. You can see the network call right here. It's calling the ELB service. and the ELB, we have configured it to be linked with the ECS service, thereby served through the container application, right? So you can see it has returned me an array of misfits, and now I have six misfit creatures right now. So each one of them has an age, description, and some other attributes. So those are the attributes that is listed down here. So what we are going to do here today is, guys, we are going to set up our CI/CD pipeline, and we'll change one of these creatures information and push that code change onto AWS code commit repository. Then we will watch our code pipeline get started, and once it is completed, we'll refresh this page and see if the updated changes are visible in our web application. All right, so that's what we are going to do. So I'm heading into the GitHub repository, the README file that we've been following along, and we are at the module 2 and module 2B, in fact. So this is about automating deployments using AWS Code Services. This is the diagram we just saw. And very first step is about creating an S3 bucket for code pipeline artifacts to be stored, right? And we discuss when the code pipeline goes through each stages, committing stage or the source code stage to build stage to deploy stage, there are artifacts that is outputted from each of those stages, right? So those artifacts, we are going to save it in S3 bucket so we can use it in the subsequent stages. So in order to save those artifacts, we are going to create an S3 bucket. So just copy this command and go to your IDE and paste it, and let's change the name for the log file or the bucket we are hosting our logs. I'll call it AWS Misfit Logs. Make sure this name is unique. So now the bucket is created. Now this bucket must have some permission, otherwise we cannot read or write to this bucket. So if you consider this bucket, guys, who wants this access? Basically our code pipeline, code build, and code commit services might need access. So we have to configure our access policy accordingly. So that policy is, you can find it inside AWS-CLI folder. You can see there's the file called artifact-build bucket policy.json. And here's the policy document. Now have a look at this, guys. So basically it's going to have two main statements. So the first statement is about getting or the reading the files, and the second statement is about putting any files into this S3 bucket. So who can read the information or the files from the S3 bucket? Basically that is defined by the principal, and here we have to specify the code build ARN and the code pipeline ARN. So those are the main two services that's going to read from this file as well as write to this file or the bucket. So we have to specify these principles in this array. So I'm going to go into my CloudFormation stack, since that is the place where we will have all the information. So if you guys can remember, we have started this stack couple weeks back, and these are the output that it generated. And here you can find those corresponding ARNs. Here the code build ARN, just copy that and paste it here. And we need code pipeline as well, since code pipeline is also pushing and reading from the log bucket. Okay, just copy these two lines and replace it here as well. This is about putting the information or writing the information of files to the bucket. So those two are the same. And then we have to replace the bucket name here. So my bucket, the one I just created, is called AWS Misfit Logs. Just replace at both the places. Alright, this will do. So we are going to push this bucket policy into this S3 bucket. So how can we do that? So I'm going to use AWS S3 API put bucket policy CLI command. Just copy that and come back here, paste it in, and you have to replace your bucket name at the middle. Let me just navigate to that place. AWS Misfit Logs. I renamed it with my bucket name and hit enter. Well, I get an error. It says specified bucket does not exist. Maybe I might have done a spelling mistake. I'm going to rerun the command with the correct bucket name and hit enter. There you go, it's created. Okay, now the bucket pulse has been pushed into the bucket. So we can just verify that if you go to your S3 bucket and in the permission section, you go to the bucket policy and you should see this, right? If it is not visible, do a refresh, then it should appear. Okay, that's the first step. And the second step is we need to create a code commit repository because at the moment we don't have any code commit repository. So we'll create that and then we'll copy the existing code into the repository. So in order to create a repository, there's a simple command, CLI command. Just copy that from the documentation and get here, paste it in and hit enter. There you go, it's created. You can just verify that if you go to AWS console and search for code commit. In the code commit, you can see the repository link here and go there and you should see the newly created repository. Give it a second. There you go. This is it. Now the next step is to build a code build project. Right now we have the code repository. So when we push some changes into the code repository, we should have a code build project that get triggered and build our code. So in order to build the code build project and copy this particular command and clear the console, paste it in. But before pressing enter, let's look at the code build project.json file, which is right here in the AWS CLI folder. And there we have to replace some placeholders like account ID as such. So I will go to my CloudFormation stack outputs and copy the relevant information there, account ID here, and the default region. And now we need to provide an IAM role for code build. So that is also we can copy from here, code build role ARN. This role will specify what can the code build do and paste that in. And finally, we are going to set the code build source as code commit project. And we are going to replace the code commit ARN, the code commit repository we just created, get the ARN and paste it here. So basically, I just have to replace the region here. That's it. It looks all good. We can see the environment is of small, general, small, easy to instance. And we have an base image of Python 3.5 because our application is a Python Flask application. And if when the code builds start building the Docker file, there are Python based commands. So in order to run those commands, we need to have Python in the environment. So we'll use Python 3.5 image as the base image. Okay, just save the changes and now hit enter. Okay, now it's created. Now the next step is to configure our code pipeline. Now we mentioned the code pipeline is the glue between all these CI/CD services, right? So in order to create the code pipeline, let's use this command. Clear the screen, paste it in. Before hitting enter, let's go to code pipeline.json file and see what are the placeholders we have to replace. First, we need to specify the IAM role for the code pipeline, which we can copy from the stack details. So this is the role name for the code pipeline and paste it in here. And then we have the stages of the code pipeline. And there are three particular stages. And finally, the artifacts will be stored in the S3 bucket. So let's replace the S3 bucket name here. So I'll copy this S3 bucket name and paste it here. And let's see what are the configuration we need to provide at each stage. If I expand the first stage, this is the source stage. So source stage is linked with the code commit. That is where our source is live. Well, there's nothing much to be configured there. And the second stage is the build stage. So it is linked with the code build project we just created. Nothing much to fill there as well. And finally, the deploy stage. Now at the deploy stage, we are going to deploy to ECS, right? So we are going to use the provider ECS in order to use the Docker image that is built and create a container and deploy a new service. Okay, so that is happening with the code deploy stage. Okay, it looks all good, so I will save it. And now I'm going to hit enter, see if there are any issues. Well, it looks like it's created without an issue. Now let's have a look at the code pipeline service as well. I will open it in a new tab and have a look. If you go to pipelines under pipeline, you can see the new pipeline is created. And if I click on that, you can see our stages has been created. This is the source stage, build stage, and deploy stage. And source stage is linked with code commit repository. Build stage is linked with our code build project, and finally we are deploying to ECS. And one final step, we need to configure the policy for ECR or Amazon Elastic Container Registry, where our build stage is going to deploy the built image to. So we have to configure a little bit of permission there as well. So I'll copy that URL or the command and paste it here. And before hitting enter, let's inspect ECR policy.json. So this is the policy we are going to attach to ECR. And basically what we need to specify here is allow code build to push images to ECR, right? So the principal or whoever the person who's doing the action is our AWS code build. So let's replace our code build ARN here. I'll go to stack details and let me find the code build role, and this is it. And I will replace the role ARN right here. And we are allowing the actions put image and get image, all that. So our code build will be successfully pushing the image to ECR. Save that, and now let's hit enter. Beautiful, it's created. So that's all about the configuration stuff. Now let's clone our repository and push our application code into it. Now before cloning the project, let's set some variables like the username, email as such. So I will just copy these git config commands and hit here about the username. I will replace it with my name, and we also have to replace our email. So I will add a mock email here as well. And for credential to use HTTP path, enable it. Okay, now that we have configured it, it's time to clone our repository and push the existing code into it. So I'm going to cd into my code 9 environment. Okay, now I'm at the environment level. Now let's clone our code commit repository, which is at the moment empty. That's fine. So I will replace it with the region name and hit enter. You should see there's a new folder is being created. There you go. This is that new folder. So any file that we put into this folder can be staged and can be committed and push it to the code repository. Okay, at the moment our folder doesn't have anything since our repository itself is empty. So we're going to need to copy some application code from our module 2 into this folder and then push that changes into the code repository. So let's do that. I will use the copy command, and so it's basically copying recursively from the app folder content, module to app folder. That means all the content inside this file, because we need a build spec file for our code build to be initiated properly, and we need the Docker file for our code build to build the Docker image file as well. And we are copying all that files into our repository in this folder. Now I'm going to hit enter. Okay, looks like it's created. Let's double click this folder and you can see the files are indeed being added. Okay, now we need to push these changes into the code repository. So as soon as I push the changes, my code build project should start, and then finally the code deploy will happen and deploy a new container into the ECS. So let's do a change to one of our misfit creatures age. I will go to the service folder, and here I should see the misfit response.json, and there I have this creature Evangeline, I believe, and right now its age is 43. I will change it to 900. So the creature I'm referring to is this guy, and his age currently is 43. Now I just changed to 900. Let's add that change, git add dot to add all that. Okay, but we need to be inside the code repository. So right now, if we check the present working directory, I'm in the environment. So I need to go to mythical misfit repository, and now I need to do the git add space period. So that will add all the files. Then I will add a commit message as well, -m change Evangeline's age to 900. A commit message, and I'm going to push it. So this is going to push the code into the repository. Okay, it is now pushed. Now we can actually inspect our code pipeline. and see if it triggers a build. So I will go to the code pipeline, and you can see it already has been started. The source stage is created or the succeeded, and now the build stage is in progress. Beautiful. So let's give it a second. So at this build stage, it's going to create the Docker image from the Docker file and then push that image to ECR. All right, so build stage is now succeeded, and now it's going to start the deploy stage. Let's wait for it. There you go. So it started. So at this stage, it's going to basically use that built image from the ECR and create a container and create a service and deploy to ECS. So once this is completed, we can refresh our front end and see if that change is visible. And just a quick recap about our front end, how it is set up. Our front end is pointing to a elastic load balancer, a rather network load balancer, and that network load balancer has a target group that is pointing to the AWS ECS service. And at this deploy state, it's going to update that service. So everything is then connected. So as soon as I refresh the front end, it should refer to the newly added service. Thereby, it will serve from the newly added container, right? Alright guys, so now the code deploy stage is also completed. It took about 6 minutes to complete the pipeline. So now let's check if everything is working. So I will clear the console and I'm going to hit refresh. Very nice. There you go. The age is 900 for our Evangeline. And as you can see, this has entirely automated the deployment process for our developers. So as soon as a developer develop a new feature and update a feature or bug fix, it will be automatically be deployed to the production. So it's going to save a lot of development time for the developers when it comes to deployment, since the deployment is fully automated, and that's the power of CI/CD pipeline. Okay guys, I think that's it for this video, and I'll see you in a new video. Thanks.